Hello and welcome to this video lesson on plate tectonics. Recently in class, you've learned the theory of plate tectonics, that the Earth's lithosphere is broken into giant pieces called tectonic plates that are moving on top of the asthenosphere due to convection currents in the mantle. The location where these plates meet are called plate boundaries, and there are three basic types of plate boundary movements and interactions that result in specific geologic features on our planet. After viewing this lesson, you should be able to describe the movement and interaction of three types of plate boundaries: convergent, divergent, and transform. Explain the resulting geologic effects for each type of plate boundary, and identify specific geologic features around the world and explain how plate movement is responsible for such events. In yesterday's lab, you used graham crackers and Cool Whip to model the lithosphere and the asthenosphere respectively. Let's talk about how you moved the graham crackers, what you observed, and what you modeled in each experiment. In experiment 1, you pushed the graham crackers away from each other while keeping them connected with the Cool Whip. This modeled a divergent plate boundary. When two continental plates diverge, the crust between them buckles and falls, creating a rift valley and earthquakes. And as the plates split further apart, water eventually fills the space. The East African Rift Valley is an example of this. When two oceanic plates diverge, it creates a chain of underwater volcanoes, or a mid-ocean ridge, as well as earthquakes, as illustrated in this simulation. An example of this is the Mid-Atlantic Ridge. It runs along the middle of the Atlantic Ocean. In experiment 2, you slid the graham crackers past each other, keeping them connected to each other and the Cool Whip. This modeled a transform plate boundary. When two plates are trying to move in opposite directions, a lot of tension and energy builds up. When one plate finally shifts, this causes earthquakes. These boundaries can be found in the ocean connecting diverging segments of a mid-ocean ridge. Another example is in California, the San Andreas Fault. In experiment 3, you pushed the wet grahams toward each other and they folded and pushed upwards. This modeled a convergent boundary where two continental plates pushed together to form non-volcanic mountains due to the similar densities of the crust. This is how the Himalayan mountains were formed and are still forming, because the Indian plate collides with the Eurasian plate. In experiment 4, when the grahams collided, one plate went under the other one. This is called subduction. This happens when an oceanic plate collides with a continental plate because the oceanic plate is more dense. When two oceanic plates collide, the plate that is older will subduct. A deep ocean trench is formed at this boundary, and subduction causes melting in the overlying plate, leading to magma rising to the surface and creating volcanoes. The Mariana Trench is a famous example of an ocean-ocean convergent boundary, as the deepest point on Earth, Challenger Deep, is found here. A good example of an ocean-continental convergent boundary is the Andes Mountains. The volcanic Andes Mountains were formed from the Nazca Plate in the Pacific Ocean colliding with the South American continental plate. So we just covered a lot of plate tectonics info. To summarize what you've learned about the plate boundaries, remember this song. Convergent is colliding, divergent is dividing, transform is sliding, these are the plate boundaries. Convergent is colliding, divergent is dividing, transform is sliding, these are the plate boundaries. Hopefully after watching this video you have a better understanding of the three types of plate boundaries, the features that are found at each, and some examples of plate movement around the world. Please let me know if you have any questions, and best of luck in your continued studies in plate tectonics.